Okay, this one is 946, and we have a nonlinear volt-amp characteristic that's being modeled with these straight line segments. And each of these represent the different regions of operation of the diode. And this is 2 volts, and this is 1.2 volts, and this is 0.8 volts, and this is 1, and this is 10, and this is 11. And these, you model each of these segments with, this one is with a resistor, and this one is with a voltage source, a positive voltage source, and a resistor. So it looks like a resistor and then a positive voltage source, and then this one looks like a resistor and then a negative voltage source. So this is the what we call the operating region. This is before it turns on. Usually that happens at 0.7 to 6 volts, so you have very little current there. And this is I'm forgetting what we call it. Hold on, let me get the right terminology. Okay, I'm not sure. So, and this is in milliamps. So for this first segment, we just need to figure out what the resistance is. So that would be 0.8 volts over 1 milliamp, or 0.8 over 0.001, which equals 800 ohms. Okay, so for our next segment, that's the operating region. So the voltage is going to be 0.756. And so we can figure out what the resistance is, because we can see that we have from 0.8 to 1.2. So it's going to be 0.756. So 0.756, because that is the forward voltage of a diode. So that's the number that you use. That's just it. Plus IR equals the difference between these two, which is 0.4. Well, we know what I is. I is 10 minus 7? 1. 10 minus 1, 9. And so we get lost my work. Okay, so 0.756 plus IR equals 1.2 minus 0.044. Then subtract 0.756. 0.756. Oh, I'm sorry. I thought I had paused it during all that time. Okay, I'm sorry. So 0.756 plus I, so I is the difference between here and here is 9, times R equals 0.0444, and then subtract, oh, that's not right. I'm losing my mind. I don't even remember what I was doing. So 0.756 volts plus, so that's 9 milliamps. That's really 0.009 amps times the resistance. Where did I get this 0.044 from? I have an answer of something. What did I do? I don't know why I divided it by 9. Yeah, ignore me. Yeah, all we need to do is find the resistance from the slope. We know that this piece is going to be the 0.756 because it's in the operating region, and then we just need to find the resistance. And so the resistance, V equals IR, will be V over R, and V is 1.2 minus 0.8 is 0.4, divided by the resistance is 0.09 amps, and that is 4.44, which tells us that this middle part here has the voltage of 0.756 and a resistance of 4.44. This was supposed to be 0.09, which would make it 44.4. Again, to say where this came from, this is 10 minus 1, that's 9 milliamps, which is 0.009 amps. And so we had the change in the voltage 0.4 over 0.009, and that gets us the resistance at 44.4. So that's this part. This last part, we're in the breakdown region. We can still get the resistance the same way, so that would be the run, which is 1 milliamp, over the voltage, which is going to be 0.8, which gets us 1.25. Okay, so there's a mess on the screen. I should probably just start this one over. So if I get the slope of this segment of the line right here, that would be 0.8 over 1 milliamp. So that'll get me 800 ohms again. But this time we would have that we are reverse biased. So we have minus plus, and we have, I am really just drawing a blank on this one. I'm not sure how they came up with it. My best guess is that we get the resistance. That's not so bad. We did that, but then we must be in a breakdown region, I guess, and it must just be a known value, just like our 0.756 is a known value, and this known value is negative 6 point something, negative 6.8. So I'm just going to go with that. So I mean, don't know. So this part just going to be a resistance, and you find that by taking the voltage over the current. This part is going to be the operating region, and that's going to have a positive voltage source and a resistance, and the positive voltage source is going to be the value of 0.756, and then you can do 0.756 like we did up here plus IR equals 0.4, and then in this last region you can get the resistance again with, that's how you got the R here. You get the resistance again from the slope, and then it'll be a negative voltage of negative 0.68, and we'll just assume that that's the way they did it, because I don't have a better answer. And then it says use these equivalent circuits to find V for the circuits shown in these. So we have our mystery device right here. We have 3 kiloohms and 15 volts, and you figure out by trial and error under which segment of the graph it's operating under. I'll show you, hold on. Let's say I assume it's operating under the middle segment, and if I assume it's operating under the middle segment, then I assume that this is the 44.4 ohm resistor, and this is the plus 0.756 volt voltage source, and then I see if it works. And so to see if it works, that means I've got a net voltage of 15 minus 0.756. So I take this voltage minus that voltage, so that's my net voltage, and I divide that by my total resistance, that's 3044.4, and that gets me a current value 4.68 milliamps. And now to test to see if I was correct here, I take this current that I got, and I figure out the voltage drop across this resistor. So 0.00468, I think that was the amount I got, times 44 ohms. And I do that, I get 0.20592. I add that to my 0.756. And I get that my voltage from here to here is 0.96192, and that would make it that would be in the operating region. I do have the necessary voltage to be operating in that region. I just have to be above 0.756, and I am. So that works. Now, for the second one, we have to try to decide under what condition it's operating, and don't know how to tell just from looking. Yeah, so all you can do is try out the different models and see which one works. And so let's try out the model where we would have it be in breakdown. So if we try the one on the top one where it's in breakdown, then I'll model it with an 800 ohm resistor and a minus 6.8 voltage source. We've got a 40 milliamp current source right there. So how do I want to solve this? What are we looking for anyway? We are looking for V, so we're looking for the voltage across it. So to get the voltage across, I need to know the current through the 800 ohm resistor. So let's do a source transformation on these. So a source transformation, when you have a current source and a resistor in parallel, you can turn that into a voltage source and a resistor in series. So that becomes a 50 ohm resistor, and our voltage source becomes 0.04 times 50, which is 2. So I can find the current here would be 2 minus 6.8, negative 6.8 over 850, which is 8.8 over 850, which is 0.0103. So that's our current. So what is our voltage across the 800 ohm resistor? It would be 0.0103 times 800. Not divided. 0.0103 times 800. 8.24. So that means the total voltage across from here to here is 8.24 minus 6.8, which is 1.44. volts. And then we can tell that's in the correct region of the graph because we look at the 1.44 volts and we go back and we look at our graph, and that was in fact in the 1.44 region, just like in our first one where we got 0.96192. That was right here in this region, and so that we did choose the right one. If we had not chosen the right one, if we had chosen a different model, once we found our voltage, we would have found that it was in the wrong region of the graph.